Hey guys, how's it going? All right, so let you know what we're starting right now. What we're doing is called rational expressions. Okay, this is a topic that has a lot of applications when you start doing calculus down the road. A lot of the formulas you're using like this would be having to, understand and work well with rational expressions. Okay, so we are just working on some of the skills that you will need for down the road for that unit. First topic is called simplifying rational expressions. Okay, so example one, very simple like that, but it's like you would have learned in junior high how to simplify fractions. Okay, I'm going to do this question in two ways here. Okay, so first way is if you do the fraction 12 over 15, I think what you would see is like you would just say divide by 3 and then divide by 3 at the top and the bottom by the same thing. 12 divided by 3 is 4, and 15 divided by 3 is 5, okay? So this is definitely a good way of doing a question like this. I'm going to show you a different way of doing this question over here. And it's really doing the same thing that we're doing over here, but we're kind of showing it in a slightly different way. And what we're going to do is we're going to factor the top and the bottom of this fraction. And what I mean by that is, well, number 12 is the same thing as 3 times 4. Okay, so we can do this. And now the fraction 15, number 15, is the same thing as 3 times 5. So what we're doing here is that if we factor the top and the bottom like this, and well, if we have a common factor in the top and a common factor in the bottom like this, well, this is like really the same thing as saying, well, what's 3 divided by 3? Well, 3 divided by 3 just cancels out like this and becomes 1 like that. And that's where we're left with 4 over 5. Same idea, if I'm doing 18 over 24, well, this is going to factor to 6 times 3. And this is going to factor to 6 times 4, okay? So it works so that a common factor in the top of 6 and 6, we can just cancel those guys out, and we're left with a fraction of 3 over 4, okay? We're going to be applying this strategy to questions later on in this section over here as well. So first of all, what's a rational expression? I'm going to say the definition is kind of a nasty definition over here, but it makes more sense with the examples in a sec. A rational expression is an expression in the form p of x over q of x, where p of x and q of x are polynomials, and q of x cannot equal 0. So example, x minus 3 over x plus 2 is just an example of a rational expression. So this is a polynomial, x minus 3 is a binomial, and this is a binomial as well. Okay, so this doesn't really matter, but this is an example over here. Now, the rule, we have a math rule that says you are not allowed to divide by 0. Okay, so you are not able to divide by 0. Okay, and that's what we're saying this part over here. So the bottom part is where we're dividing by q of x. Q of x is not allowed to equal 0. So now we need to think, well, what value of x makes the entire denominator equal to 0? Okay, well, if x plus 2 cannot equal 0, and if I go minus 2, that means x cannot equal negative 2. And that's where we get this guy. We call this, we may call this guy a non-permissible value. We may say this is a restriction on the denominator. It's another thing you may say. Okay, so this is like we call it non-permissible value or restriction on the denominator. If you look at this guy over here, so this is another example. So we have x plus 5, and then we actually have a degree 2 polynomial on the bottom because x squared minus 16 is a rational expression. So our non-permissible values are actually plus or minus 4 because 4 squared is 16 minus 16. That would make a 0 on the bottom, so x cannot equal positive 4. And the same thing for negative 4, because negative 4 squared is positive 16. 16 is also 0, right? So these are our non-permissible values for this question over here. X cannot equal plus or minus 4. Okay, so example 2, reduce each rational expression, state any non-permissible values. So you're going to see lots of questions in this section similar to this, okay? So like we did in that example 12 over 15, where we factor this guy to 3 times 4 and 3 times 5, and then cancel those guys out like this, we're going to do the same thing. Well, if I look at my numerator, 4x plus 12, we have a common factor of 4, and we're left with x plus 3. On the bottom, 8x minus 20, I also have a common factor of 4. So I get 4, then I'm left with 2x minus 5. Okay, so I'm going to factor to 4 like this. Now I have a 4 on the top and a 4 on the bottom. those 4s divide by each other and we just get a 1, so they cancel each other out. Okay, so our simplified or our reduced rational expression is x plus 3 over 2x minus 5. So here's our reduced rational expression over here. For our non-permissible value, we're going to look at the denominator, 2x minus 5. Well, 2x minus 5 is not allowed to equal 0. Now it's going to solve this inequality for x. So I'm going to add a 5 to both sides. That means 2x cannot equal 5. And then if I divide by 2, x cannot equal 5 over 2. So this is our non-permissible value. Sometimes we denote this as NPV, non-permissible value over here. And here's reduced rational expression over here. Similar for for the next one, 5x minus 15 over x squared minus 3x. The strategy for this question is you want to factor everything and then cancel out common factors. So if we have a 5x minus 3, that's how this guy's going to factor in top. It's a common factor of 5. And in the bottom, we have a common factor of x, this. So in this case, the x minus 3 is going to cancel out, and we're left with 5 over x. Okay. Now, when we're looking at the non-permissible value, we're looking at the entire denominator. So originally, x minus 3 was a part of our denominator because it was in this part over here. So if I'm thinking, well, what makes my denominator 0? Well, first of all, here or here, if x is 0, I have 0 times 0 minus 3 is going to be 0, right? So x cannot equal 0. But also, for this one, x minus 3, if x is equal to 3, it's going to make this part equal 0, which would be 3 times 0, which would also equal 0. So in this case, I have two non-permissible values. X is not allowed to equal 0, and x is not allowed to equal 3. And here's my reduced rational expression for this one. Okay, same idea for example 3. It's a little bit more difficult, and it's a bit more difficult because we have a bit more work to factor these guys. Okay, so this unit, guys, there's going to be a whole lot of factoring, and it's that, and I hope that we are getting good with these skills. So the first one, this guy factors to x minus 6, x plus 2. Double check that on your own. On the bottom, this guy factors to x minus 6, x minus 1, like that. So let's see over here, let's do our non-permissible values first. X cannot equal, well, an x value of 6 will make this equal to 0, which will make the whole thing equal to 0. Or an x value of 1 here will make this part equal to 0 and this part equal to 0 as well too. So here are non-permissible values. Okay. Now I have a common factor of x minus 6 and x minus 6, so those guys can cancel out. And my reduced fraction is x plus 2 over x minus 1 is my reduced one over here. Okay. Similarly, for x squared minus 4x, x squared minus 16, I'm going to factor everything x times x minus 4. So in the top, there's just a common factor of x that we can take out. The bottom is a difference of squares, which factors to x plus 4, x minus 4. I'm going to do my non-permissible values first. X cannot equal, well, it's negative 4 or positive 4, plus or minus 4. And these guys cancel out. So it's x over x plus 4, like this. So this is my reduced version of this question over here. Okay. The thing that's tempting over here, in both these examples here, we're not able to cancel out this x and this x. And the reason is, the rule is we're only allowed to cancel out factors. Okay, and so this is factors when something is something times something and something times something. Well, you're allowed to cancel out these guys because they're common factors. But like this is not x times 2, this is x plus 2, and this is not x times negative 1, it's x minus 1. So I'm not allowed to cancel out the x's here in the same way that I'm not allowed to cancel out these x's over here as well, okay, because they're not factored like they are in this step over here. Okay. All right, guys, I hope that gives you a bit of an intro to this topic, and please send me a message if you have any other questions. Okay, talk soon. Bye.